Assalamualaikum and hi. Today I will present my research project entitled Synthesis of Ethylenediamine-Modified Hypercrosslinked Polymer and its preliminary study of antipyrine and Pamabrom extraction. Here is the outline for this presentation. Let's start with the introduction. Pharmaceutical compound belongs to the class of emerging contaminants that have been identified in low concentration in the environment. Some residues will remain and be present in very small concentration in wastewater treatment plant after the continuous release of pharmaceutical in the sewage system. The analysis of pharmaceutical pollutant can be very challenging due to the low trace level concentration and their existence is complex mixture of pollutant from different chemical classes. Therefore, dispersive solid phase extraction (DSPE) is the most preferred technique available for rapid and selective sample preparation due to their low cost pre-treatment technique and higher extraction yield. The polymeric material was synthesized consists of three monomers, which are acrylonitrile, laminal benzene active cross-linked monomer, vinyl benzyl chloride as a hypercrosslinked monomer. The third polymer was then hypercrosslinked to develop the hypercrosslinked 3D network structure via Friedel-Crafts reaction, and the hypercrosslinked polymer was further chemically modified with ethylene by converting the nitrile group into diamine moieties. Antipyrine and Pamabrom was chosen as subjects in this study. The presence of pharmaceutical compound as low level contaminant in water has raised public concern in recent years due to their potential toxic effect on human and aquatic life. And most of existing solvents have poor capacity and selectivity, besides it's difficult to dilute some of the compound. Therefore, our research approach is to prepare a 3D network hypercrosslinked polymer as an adsorbent with high capacity, and the chemically modified hypercrosslinked polymer that has been produced helps in tuning selectivity toward the extraction of polar compound. And here is the research objective of this study. Our research novelty is the highly cross-linked polymer with high porosity resulted to high extraction efficiency to polar and light, and the further chemical modification of active nitrile group in the hypercrosslinked polymer provide better selectivity with weak and ion exchange character. Thus, the preliminary study was carried out for the extraction of antipyrine and Pamabrom from the aqueous solution. And here is the research methodology involved of preparation of modified hypercrosslinked polymer and the DSPE procedure. Consists of absorption of analyte, separation by centrifugation method, the removal of aqueous phase, and the elution with the organic solvent before the sample sent to the GCMS analysis. Result and discussion. From the FTIR spectra of third polymer, we can see the presence of C double bond and imine group at the exertion peak of 144 cm negative 1, and also the chloromethyl group will almost disappear after hypercrosslinking reaction as observed in hypercrosslinked polymer spectra. For the modified hypercrosslinked polymer, the new exertion peak was appear at 3379 indicates the presence of enhanced stretching in which the successful chemical modification was carried out. The microanalysis showed that the chlorine content of the polymer was significantly decreased after the hypercrosslinked reaction, indicate the hypercrosslinked reaction was successful, and the nitrogen content was increased after chemical modification with EDA indicated the successful chemical modification of the microsurface. From the SEM image, we can see that all sample with a ratio of 35, 60, and 5% of ANDVB/VVC are in the form of spherical beads with monodispersed microsphere. Meanwhile, on SM image of adsorbent with ratio 40, 55, and 5% of ANDVB/VVC are in the form of agglomerated particle. The BET surface area analysis showed that the highest specific surface area was obtained by hypercrosslinked polymer, which was up to 2274 m² per gram. And after the chemical modification with EDA, the BET surface area decreased to 503 m² per gram. This might be due to this disruption of the wall within the hypercrosslinked polymer as the end unit was chemically modified. For the SPE extraction analysis, for the effect of adsorbent mass, for antipyrine, the EE% of modified polymer is the highest in all adsorbent dosage. However, there is no significant change on the EE% of terpolymer, indicate that the availability of the active surface of terpolymer was not dependent on how much the mass of adsorbent was used. Meanwhile, for Pamabrom, it showed that the EE% of modified terpolymer and hypercrosslinked polymer will significantly increase and the adsorbent mass was increased to 50 mg. It can be concluded that modified polymer was more favorable for the extraction of antipyrine with a maximum EE% at 95% compared to the Pamabrom at 54%. Next, second is the effect of extraction time. For antipyrine, the results show that the EE% of terpolymer was higher compared to hypercrosslinked polymer and modified hypercrosslinked polymer at 10 minutes of extraction time. This observation showed that the extraction time by using hypercrosslinked polymer and modified hypercrosslinked polymer was very significant due to the faster uptake at that extraction time. And after the 10 minutes, the extraction time became lower. Meanwhile, for Pamabrom, it can be observed that the EE% at 10 minutes by using all adsorbent there were only small differences in the EE, indicated that Pamabrom was not particularly selective toward hypercrosslinked and modified hypercrosslinked polymer only because it also has good electrostatic interaction with terpolymer as well. For the effect of elution time, the EE% for antipyrine was the highest for hypercrosslinked polymer at 10 minutes of elution time, 532%, showed that the desorption of antipyrine was favorable from the surface of hypercrosslinked polymer, and the EE% of all adsorbers were almost the same as the elution time were increased to 15 minutes. Meanwhile, for Pamabrom, the highest EE% was achieved by terpolymer at 5 minutes of elution time, and then the EE% was the highest for modified polymer at 10 minutes of elution time. It can be concluded that the desorption of antipyrine was more feasible, which is with the EE% up to 532% as compared to Pamabrom only up to 100%. This is the proposed interaction mechanism between the modified hypercrosslinked polymer with antipyrine and Pamabrom. It was found that modified hypercrosslinked polymer has better selectivity toward antipyrine due to their existence of strong pi-pi interaction between antipyrine and the adsorbent that enhance the extraction efficiency. So the conclusion is that all the polymer was successfully synthesized as a polymer adsorbent, and the preliminary study showed that the hypercrosslinked polymer and its modified version have potential to extract antipyrine in Pamabrom for aqueous solution. It has shown that the modified hypercrosslinked polymer has higher extraction efficiency to the antipyrine as compared to the Pamabrom. Here is the list of my publication. Thank you for your time.